Welcome back, dear children. Today we move on to the third part of quadratic equation. Nature of roots. We have already learned how to find the roots of the quadratic equation with the help of quadratic formula. And we have seen b square minus 4ac is called as the discriminant of the quadratic equation. Since b square minus 4ac determines whether the quadratic equation has real roots or not, we call it as the discriminant. So based on this, we can say if the discriminant is greater than 0, that is b square minus 4ac is greater than 0, we can say the quadratic equation will have two distinct real roots. If the discriminant b square minus 4ac is equal to 0, then we can say the quadratic equation will have two equal real roots. And the last case, if b square minus 4ac is less than 0, there are no real roots. Let us see how to find the discriminant and the nature of roots with the help of an example. The question is 2x square minus 4x plus 3 equal to 0. Here a is equal to 2, b is equal to negative 4 and c is equal to 3. Therefore, discriminant, that is b square minus 4ac is equal to negative 4 square minus 4 into 2 into 3, which is equal to 16 minus 24, which is equal to negative 8, and it is less than 0. Since b square minus 4ac is less than 0, we can say there is no real roots for the given equation. Here we are going on to the exercise 4.4, page number 91. Second question. Find the value of k for each of the following equations so that they have two equal roots. First question. 2x square plus kx plus 3 equal to 0. Here a is equal to 2, b is equal to k, c is equal to 3. It is given the equation will have two equal roots, that is b square minus 4ac equal to 0. We can substitute the values. We have k square minus 4 into 2 into 3 equal to 0. It will be k square minus 24 equal to 0. From this, k square is equal to 24. Finding the square root, we can say k is equal to root 24. By simplifying, it will be plus or minus 2 root 6. Question number 3. Is it possible to design a rectangular mango grove whose length is twice its breadth and area is 800 meters square? If so, find its length and breadth. Here the length and breadth both are missing, but we can see a clue is given is length is twice its breadth. So let us assume breadth is equal to x. Therefore, length will be 2x. Also given area is equal to 800 meters square. Area of a rectangle is L into B. So substituting the value 2x into x equal to 800, we have 2x square equal to 800. From this, we can find x square is equal to 400. Taking the square root, x is equal to root of 400, which is equal to 20. That means breadth is equal to 20 meter and length is equal to 40 meter. Is the following situation possible? If so, determine their present ages. The sum of age of two friends is 20 years. 4 years ago, the product of their ages in years was 48. In this question, age of both friends are not given. So let us assume age of the first friend is equal to x. And as it is given sum of age of two friends equal to 20, we can take age of the second friend is 20 minus x. Now we can see 4 years ago age of the first one will be x minus 4 and age of the second friend will be 20 minus x minus 4, which is equal to 16 minus x. Given product of their ages equal to 48. That is x minus 4 into 16 minus x equal to 48. Multiplying x minus 4 into 16 minus x, we have x square minus 12x plus 64 equal to 48. Transposing 48, our equation becomes x square minus 12x plus 16 equal to 0. Applying quadratic formula, negative b plus or minus root of b square minus 4ac by 2a, we have 12 plus or minus root of negative 12 square minus 4 into 1 into 16 by 2. Simplifying, finally we have the answer 6 plus or minus 2 root 5, which is not possible for the age. Let us continue exercise 4.3. In the last class, we have learned only normal questions based on solving the quadratic equation. Here we move on to the word problems. Question number 4. The sum of reciprocals of Rahman's age 3 years ago and 5 years from now is 1 by 3. Find his present age. The question is to find the present age. So let us assume the present age is equal to x. So age of Rahman 3 years ago, it will be x minus 3, and 5 years from now will be x plus 5. As per data, it is given sum of reciprocals of the age is equal to 1 by 3. Reciprocal of x minus 3 is 1 by x minus 3, and reciprocal of x plus 5 will be 1 by x plus 5. Adding this equal to 1 by x plus 3 plus 1 by x plus 5 is equal to 1 by 3. Cross multiplication method, on the left hand side we have 1 into x plus 5 plus 1 into x minus 3 by x minus 3 into x plus 5 is equal to 1 by 3. By simplifying, we have left hand side is equal to 2x plus 2 by x square plus 2x minus 15 equal to 1 by 3. On cross multiplication, we have 3 into 2x plus 2 is equal to x square plus 2x minus 15. Opening the bracket, on the left hand side we have 6x plus 6 equal to x square plus 2x minus 15. Transposing 6x plus 6 to the right hand side, we have our standard equation of x square minus 4x minus 21 equal to 0. Here we have a is equal to 1, b is equal to negative 4, c is equal to negative 21. Finding b square minus 4ac and root of b square minus 4ac, we have it is equal to 10. Applying the quadratic formula, negative b plus or minus root of b square minus 4ac by 2a, we obtain the answers like 7 and -3. Therefore, the roots of the quadratic equation are 7 and -3. Question number 5. In a class test, the sum of Shefali's marks in mathematics and English is 30. Had she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in the two subjects. Let us assume the mark in maths is equal to x. Then we can say mark in English will be 30 minus x, as it is given sum of Shefali's mark in maths and English is 30. Now, if the mark in maths is 2 more, we can write the mark is equal to x plus 2. So, the mark in English will be 3 less, which is 30 minus x minus 3 equal to 27 minus x. Now, the data is given as the product of their marks is equal to 210. That is x plus 2 into 27 minus x equal to 210. Opening the brackets, we can see 27x minus x square plus 54 minus 2x equal to 210. Transposing and making it the standard equation of the form x square minus 25x plus 156 equal to 0. Here a is equal to 1, b is equal to -25, c is equal to 156. Finding discriminant and taking the square root of the discriminant, we can find it is root 1 is equal to 1. Applying in the quadratic formula, we can see 25 plus or minus 1 by 2, which is equal to 13 and 12. That means if the mark for Shefali in maths is equal to 13, then her mark in English will be 30 minus 13, which is equal to 17. Similarly, if the mark is equal to 12, then her mark in English will become 30 minus 12 equal to 18.